Okay, welcome to part 3. Now, I'm not going to do these ones, so for each of these it's exactly the same as the previous one, except you just have to get to a point where you can find your initial value for theta. So for this one, you take away 5, so you'd say tan theta equals -2, and then you do inverse tan of -2, get your first solution for theta, and then just draw your graph out and do exactly the same as in the previous example. Just be aware that they only want answers between -180 and 180, so when you draw your graphs out, you'll get fewer solutions. Okay, so that's all you need to do for those ones. So this is quite tricky actually. So find the solutions for cos 4x between 0 and 180. So what is cos 4x? Let me draw that up for you. Okay, probably should have done this first time around, shouldn't I? So here's Desmos, so in blue we can see cos 4x, and in red we can see the regular cosine graph, and I've done it, which I'll talk about in a minute, I've done it between 0 and 720 degrees, so you can see it just continues to oscillate. Okay, so what are we looking at? So the regular cosine graph, y equals cos x, we know goes between, or we've looked at it between 0 and 360, or minus 360 and 360. So there's our, let's have a look at where 360 is. There we go. So that's what we've been used to. That's starting up here at 1, coming down to -1 and going back up to 1. Now cos 4x, you think of it as a graph transformation, but right now it's better to think of it as the number of extra oscillations, or the frequency of the oscillations that you get for cos x. Okay, so what it means is that everything in a particular period happens 4 times as frequently as it does for the regular cosine graph. For instance, between 0 and 360, the cosine graph goes to -1 once. But what does cos 4x do? It goes to -1, 1, 2, 3, 4 times. Okay, and it's that sort of comparison that we can use. So how do we get the solutions for cos 4x without having to draw the whole thing out? Well, what we can do, if we want the answers, let me get rid of the 360 now, of what does cos 4x do between 0 and 180? Let's have a look. Here are my solutions: 30, 60, 120 and 150. Okay, but what we can do is we can think of the cos 4x graph as a compression of the regular cosine graph. Okay, so we squeezed it in. So what we can do is, if we look at the regular cosine graph for 4 times bigger, find the answers, we can then divide them by 4. So I've gone to 720 on my scale, okay, because that's 4 lots of 180. So if we find the answers for the cosine graph between 0 and 180 and 720 and divide them by 4, that'll shrink them back in to give us what cos 4x is doing between 0 and 180. Okay, so the best thing to do is think of it like this. Imagine this little piece here. You'll notice it hits the peak 1, 2, 3 times. If you look at the regular cosine graph between 0 and 720, look how many times it peaks. 1, 2, 3 times. So if you stretch this little blue graph out between 0 and 720, you get the red graph. Okay, so we can do it the other way around. If you compress the red graph between 0 and 720, you get the blue graph, right? So you do exactly as you would do normally. So you do inverse cos of minus 0.5, and you get your first solution, which is 120. Now if you divide that by 4, compress it, you get the first solution on the cos 4x graph of 30 degrees. Okay, if you move along, having drawn your graph out, you get your second solution of 240. If you divide it by 4, compress it, you get 60 degrees. Okay, and if you keep going, there's the next solution. 480 divided by 4 gets us to our 120, and then finally 600 divided by 4 gets us to our 150. Okay, so if you just keep going with the oscillations of your cosine graph to a scale 4 times bigger, get all your answers and then divide them by 4, then that will give you the answers to your cos 4x graph. Now I will say at A level, you've got a graphical calculator that do most of this for you anyway and give you all the solutions, but that's how it works, okay? So you can now apply that to any number of questions. Just whatever the number